Hello, everyone, and welcome. My name is Adodino Sapi, and for today, I will be sharing with you a design of a three-tier type of architecture. So, we'll be looking into the architecture principle, we'll be understanding what happens on a website, what is the coupling, we'll be looking into load balancers. Just a note, whenever we are talking about websites as architects, we do not go through operations that a software developer does, such as coding or anything related to that. So, uh, what is a three-tier type of architecture? A three-tier type of architecture is the architecture that is divided into three layers, three different layers. The first one being the front end, which is where the users will interact with our application. So to be more specific, anytime you log into a website or whenever you go to a website for the first time, you will have you will have some windows to place your credentials and all that. You will input your data. That is the front end. Anything that interacts with the user. On the second layer, we will have the back end. That's where the business logic happens. So whenever you type your name, first name, last name, and then the system will understand, oh, I'm talking to Adodino Sapi. So Adodino Sapi, here is what you were looking to last time you was here. Okay, so welcome Adodino. This is the first time you're being here. So that is the back end. And then the third layer, it is where we find the database. The database is where the data is stored, as the name can tell. So anytime that Adodino Sapi uploads an image to my website, the image of Adodino Sapi will be kept in that database. Anytime Adodino mention his age, anything that is a data, it will be stored at that database. So I hope this was a very basic explanation of what a three-tier architecture looks like. So now we are going to direct understand how how we start to design and thinking of. So we are all looking at the internet. So the internet is a big space, is a big spectrum where computers need to talk to one another. But I cannot just let anybody have access to my system or my home with no any other procedures to that. So this is why we need to design and think how our system needs to look or face the internet. With that, we start with a load balancer. So we will be placing a load. Before the load balancer, we need to have an identification. An identification is just like a place, an address, and in internet world or in the networking world, we call this an IP address, which will be an external IP address. With the IP address, is very unique. It is, that imagine you being on the other side in Angola, Africa, where I come from, and I'm in the United States, and I need to send a message from one point to another. So it is very important that I know the location of which my message is going to. Hope it can be understood. So an IP address is internet protocol, is a unique address where we will be talking to or from. And then we will have, in that same space, we will need to have a load balancer. Again, a load balancer is an important, very important aspect of designing this type of systems. Why? We mentioned decoupling. So decoupling, let's think of a traffic jam. So whenever messages are getting into my system, we need to know exactly where they're going, or we need to direct them where there is somebody ready to receive that message. So it's the load balancer, and the load balancer helps in what? Load balancer helps having high availability by eliminating one single point of failure, and it also uses health check to understand who is there to receive or not. It's the same as somebody knocking at the door and saying who is there on the other side, and then that person says, oh, that's me, I'm here, I'm ready to receive you, and then boom, he gets the message. So that is the work of a load balancer. And another important aspect of the load balancer is sharing or distributing the traffic. So, and there are two different types of load balancer. Before I forget, there is a network load balancer and application load balancer. The network load balancer is a very fast type of load balancer. It will handle a more numbers of servers, a bigger number of servers, versus an application load balancer, which is way smarter, but it's too slow because it needs to process calculus and everything like that. But this is just a fundamental and a very small explanation of these concepts. So behind the load balancer, we will need to have, behind the load balancer, we need to have a web server. That's where we find a web server. And to be very clear as well, we need to understand that this is not just one server. Whenever we talk about load balancer, that means we are talking about a cluster of servers, meaning a group of servers. And web servers. And what is the technology that a web server sits on? It is a virtual machine. Just to make it clear, we have a lot of other cloud providers that have a different name for virtual machine. Somebody that is familiar to AWS will call it EC2. We know it as EC2. So behind a web server, we need another load balancer. Again, we still cannot mention or cannot say 100% that is a network load balancer or is an application load balancer, because it depends on the needs that we are trying to put in place. So before you understand the need of your load balancer, you cannot specify whether you're using an application or a network load balancer. Then after another load balancer, that's where we come to our second layer of the three-tier application architecture, which is the application server, which also sits on a virtual machine. And after that, we remain to place our last layer, which we will call the database server. It also sits on a virtual machine. But also understanding the concept of decoupling. We already having the data going through our system. But something that is a very important aspect, we cannot use load balancers on a server because we don't use load balancers to decouple the server. So first we should understand one thing. There are two kinds of operations that happen on a database. One is read, another one is write. So we need to offload the traffic from the server so that the server can be protected because it's very important. It's just like where you keep your most important things in your system. So you don't want to saturate that. And because of other other needs of having it separated from any other confusion, you will need to put things in places. So for that, we will need a queuing service. A queuing service. Let's do it like that. We need a queuing service. And this queuing service, since we are talking about building an architecture, we are talking an architecture that can be a vendor free, can work with any service provider, any cloud provider. So we will look after the Kafka for messaging. So anytime the message gets to our system, we already know this is the one that got first and this is the one we will arrange them in order. Like that, we are preventing not getting loose of any message that is getting into our system. We're already speaking of writing. What about reading? For that, we will need to read, we will need a reading replicas. Again, before you decide if you will need a read replica or not, is important you understand that there are two types of databases. One is NoSQL databases and another one is relational databases. So let's just assume we are dealing with a relational database. Okay, to make it easier, so we have here, we will need read replicas so that we will offload the reading operation from our database. And on the last part, because we can read, but it's still, there is still something we can do better here, and this is the cache. So the cache is anytime you visit a web server, a website, you can sign up for the first time, and then once you get in for the second time, you already will have things that you were doing on this website that are already stored. Like, let's say you create a cart and you place, okay, the new things that I need to buy for Christmas. You're still in November. You're planning to buy in Christmas. So that is the cache. You will be placing things so that whenever you revisit the website, they're still there. So this is called the cache, and we use Redis for that. Redis for cache. Okay, so this is it. We do have our web servers. We do have queuing service, and I think this is a basic, very, very basic. Again, there's still things that can be put in place, but just with this type of architecture, we are able to present and apply a lot of concepts. Thank you very much for your attention, and I hope you loved it.